Here are two lines. Now, the top line appears to be about twice as long as the bottom line. So, if the first line is twice as long as the bottom line, then we're going to say the first line is 200% the length of the bottom line. Another way to look at this is, if the bottom line has a length of 100, what's the length of the top line? Well, it looks to be about 200. So we can make three equivalent statements. The top line is about twice the length of the bottom line. That's equivalent to saying that the length of the top line is about 200% of the length of the bottom line. And equivalent to saying, well, if the length of the bottom line is 100, then the length of the top line is about 200. Those are all equivalent statements, and those should all be intuitively obvious to anybody at this stage in their mathematics education. But if not, the fact that these are equivalent is something you should think about. Now, whether you can see that this is twice the length of this, well, I think you can. If not, you need to kind of practice doing that. So let's look at another pair of lines. Okay, now you should go ahead and make your estimate. What percent is the top line of the bottom? If the bottom line is 100, what's the length of the top? How many times the length of the bottom is the top? It should be clear that twice the length of the bottom is going to be greater than the length of the top, so you should get an estimate. Now, one way to make this estimate is just say, well, from here to here is the length of the bottom line, so that would be equal to the length of the bottom line. So what's this as a fraction or percent of the length of the bottom line? If you think this remainder here, this distance here, is about half of the length of the bottom line, you would estimate that the top line's about 1.5 times as great. If you estimate that's about 60% of the length of the bottom line, then you could say the estimate is about 160%. Whatever your estimate, you want to try to be close, and you want to try to make it consistent, but basically you just want to eyeball it. And one of the easiest ways to do that is say, well, if this is 100, then if this on a map represents 100 miles, and I've got to drive this far, how far am I going to drive? Does it look like it's closer to 200, closer to 100, maybe halfway between? So if our estimate is about 160 miles versus 100, we would say if the bottom line has length 100, the top has length about 160. Or if the top length is about 160% of the bottom length. The top line is about 1.6 the length of the bottom line. We should understand in the first place that these are all equivalent statements and that they represent this picture relatively well. You might have decided that it's 150%, 1.5 times the length. Okay, that would be a perfectly okay estimate. You might have even decided 1.7. Now, if you decided the top line was twice as long as the bottom, then you maybe need to adjust the way you're looking at the picture, because it's clearly the bottom is greater than half the length of the top. Now I can add one more statement to each of these. For these two lines, from bottom to top, the length appears to change by factor 2. Factor indicates a multiplicative factor, something that you multiply something by to get something else. So if we multiply the length of this by 2, that means there's a factor of 2. It also means the ratio of the top to the bottom is 2. And I might want to write that in. Don't have a lot of room, but I might want to write it in anyway. Here, the bottom to top, the length changes by a factor of 1.6. It means you multiply this length by 1.6 to get this length. Very important to understand the meaning of the word factor. Okay, so I've made a slight modification here. I say the factor is not exactly 2. The factor is approximately 2 because we have that word about throughout here. Okay, we're not making completely accurate estimates. our estimates are not going to be 100% accurate. But we think the factor is about 2 here. Think it's about approximately equal to 1.6 here. And the other statement I've added is that the ratio of top to bottom is about 2. Now I should say top length to bottom length, but I don't have a lot of room here. So I've assumed that we're, by now, we implicitly understand we're talking about the ratio of the lengths. And here, the ratio is about 1.6. So for each of these pairs of lines, we have 5 equivalent statements. So for each pair of lines, we have a total of 5 equivalent statements. 1, 2, 3, 4, 5. And these statements represent different ways of saying the same thing and help us to establish a common vocabulary for talking about such things. So the terminology implicit in these statements, actually terminology is fairly explicit. The equivalence of these terminologies gives us a reasonable vocabulary for talking about such things. And one part of the vocabulary that's probably not as familiar as others is this idea of factor. Okay? So we want to think through all these. Also, I note that people at this stage often don't really understand what percent means very well. It's a formula they learned to pass an elementary school SOL and then immediately forgot and don't really have a good feel for formulas due to probably overuse of calculators and so forth. Now here's another pair of lines. And I pose the question, okay, one of the questions here. I don't really want to, in this case, say the top line is about what fraction of the length of the bottom, because fractions can get a little bit uncertain. Now, I'll be more explicit about that in a minute. So I'm going to say if the bottom length is 100, then what's the top length? And most people are going to say either 1/3 or 1/4. And this is actually between 1/3 and 1/4 if you do fractions. If you say this is 100, then what are you going to say this is? Okay? Well, if this is 100, then this might be about 30. Okay? So if that's 30, we can do this 30, 60, 90, and maybe about 30. Maybe 28.7. Okay. We can't estimate accurately enough to say 28.7. Okay, bottom lines, the top length is about 30. So then we could say the top is about 30% of the bottom. So I'm not going to make all these statements, but I'm going to say the factor, and I'm going to put that in a different color because that's really important. So that would mean the factor would be about 0.3. Okay, if you got 30 out of 100, that's about 0.3. And that's the factor by which we change if we go from the bottom to the top. We could expand that into the entire statement, but to keep it fairly compact, we'll just say it this way. We could say the ratio is about 0.3. The ratio and the factor being the same thing once we get used to the terminology. Or the top line is about 0.3 times the length of the bottom. So we could make all 5 statements. I'm going to make 2 of them here. And now we have an estimate here. Now we could have estimated with fractions. Say this is between 1/3 and 1/4. We're not sure if it's 1/3 or 1/4. So let's go ahead and average 1/3 and 1/4. Well, how are you going to average 1/3 and 1/4? You use fractions. 1/3 is 4/12. 1/4 is 3/12, that's 7/12, and then you divide that by 2, you get 7/24. So you could say the top line is about 7/24 the length of the bottom line. That actually is a little confusing. The decimal and percent estimates are actually more appropriate to the idea of eyeballing the line, although you can use fractions to begin estimating your percent. The one thing I wouldn't want to see you do is say, well, that's about 1/3, so that's about 33.33333 repeating percent. If you write that down, I might just start asking you to estimate all lengths to the nearest atomic diameter. In other words, all those 3s are meaningless in the process of doing eyeball estimates. You want your number of significant figures to match the precision of your estimates. And just to flesh this out a little more, I have written the other statements. Top's about 30% of the bottom, ratio's about 0.3, top's about 0.3 times the length of the bottom. Okay, so all those have the same meaning. So here are 2 more pairs of lines. And you probably should just stop and think for a minute and see what you think the factor is between the lengths of these lines, bottom to top. The top as a factor of the bottom. And maybe I should write it that way. So I've expanded the question. The top is a factor of the bottom, meaning really the length of the top as a factor of the length of the bottom. And I didn't put length of in here, and I should have. But I'm going to assume that's implicit. It's important to state things as clearly as possible, as I did up here, at least as clearly as I thought possible. And then I started abbreviating my statements here. Then I gave you a very abbreviated statement here, just ask for factor. But we should understand from the context that that means the length of the top is a factor of the length of the bottom, and I'm sure that's the way you took it. But if you're writing it out, especially for the first time, you want to include all the words so that you're very specific about what this means. In any case, what do you think those factors are? Okay, just for feedback, I measured these with pretty good accuracy and determined that the top here is a factor, the bottom was very close to 0.7, to the extent that the 2 significant figures it's 0.70. Here it's about 1.12. That's probably accurate to 2 significant figures. Okay, so if you estimated 0.7 and 1.1, you hit it. If you estimated 0.6 or 0.8, you're in the right ballpark. If you estimated 1.2 down here, you're in the right ballpark. And if you estimated 0.70 and 1.12, you hit a home run. I'll comment that generally 8-year-olds can answer the question, if the length of this is 100, the length of that is 200, and so forth. A question of that nature more accurately than 16-year-olds. 16-year-olds try to figure it out. They don't go back to their original 8-year-old mind and their intuition and just eyeball the ratios. It's a skill that I think tends to be lost with pursuit of the curriculum, and I think the curriculum, although I'm not sure how that would be achieved, I don't regard myself as an authority. I think it's worth considering how the curriculum could help maintain that original beginner's intuition. You can, however, develop a pretty good intuition about this if you just draw yourself some pairs of lines and make some estimates. And then you could actually go back and measure the lines and see how good your estimates were. Get a little feedback. 30 minutes of that, an hour of that, in your whole lifetime gives you a much refined and a much better ability to estimate these things, which gives you a much better ability to visualize some of the quantities that are important in mathematics and its applications.